Hello students, I hope that you are good, well and fine. Today what we will be seeing about relations and functions. Okay. So before continuing with this, okay, we already want to recall something. Okay. And then we will jump to the definition of a real relation. What do we mean by relation? And then representation of it. And then what we will see how many or the possible number of relation from one set to another. Okay. And this we will be covering later. Okay. In this today's session we will be covering these only. Okay. So let us see, so what things we must know before uh, going to this relation definition. So we must know about what? The Cartesian products of two sets. Okay. So Cartesian product. So first of all, in Cartesian product, what we demand? We demand two sets and those set must be non-empty. Suppose P is my a non-empty set and Q is another non-empty set. Okay. Then this P cross Q, we say this is what? Cartesian product, and this P cross Q is the set of all ordered pairs of elements from P and Q. That means mathematically P cross Q is equals to the collection of all ordered pairs such that P, the first element in the pair coming from this first set, and second element of the pair coming from the second set of the Cartesian product. Okay. Okay. And what if P or Q, either P or Q is null set means empty set, then your P cross Q, the Cartesian product, will also be what? Empty. Okay, this means this. Okay. For example, if P is say 1, 2, sorry, if P is what? This set 1, 2, and 3, and Q is what set? Say X, Y. Okay. Then your P cross Q will be what? Your P cross Q will be, as you can say, the first element of the pair coming from this set, so 1. The second element coming from where? The second set, which is Q. So this means 1 comma X. I can also write 1 comma Y. Yes, this also satisfies the thing where 1 belongs to this set and Y belongs to this set. Okay. Now, can you write more elements? Yes, 2 comma X. I can do the same with Y, 2 comma Y. Now 3 comma X, 3 comma Y. Okay, quite simple. Okay, what about Q cross P? What about this? So now my the collection of pairs and the elements of the pair will be now what? Coming from where? The first element coming from this set and second element coming from this set. So this means now first element I'll be picking from this set, which means X. I can place X here, and the second element coming from this set, this means 1. Okay, I'm putting 1 here. So now X can be also placed with 2. Yes, so X comma 2. X can be placed with 3 also, so X comma 3. The same will happen for Y, so Y comma 1, Y comma 2, Y comma 3. I hope that it is clear. As you can see, what? That P cross Q set is not equal to Q cross P. Yes, the both the sets are not equal to each other. Okay. Okay. I hope that it is clear. Okay. So let us take another example for your convenience. So say A is what? AB set, and B is what? Just say C set. Just singleton element. Just single element in this set B. So this means singleton set. Now A cross B, or the A Cartesian product B, will be what? The collection of all pairs Okay. Okay. Now the first element in pair coming from where? Which set? This A set. This means this. So A can pair with C. A, okay, so that's it. Only possibility A can pair with C, no other element. Now B can pair with C. These are the only possible elements of this set. Now, what about B cross C? What about B cross A? Sorry, B cross A. Then collection of all pairs such that the first element comes from this set. This set element just C. So C comma A and C comma B. These are the only possible elements of B cross A. Okay, I hope that it is clear now. Let us move. So let us move to the next slide. Okay, so I hope that it is clear what do we mean by Cartesian product of sets. Now recall, and one more thing, that we use this term ordered pair. We used ordered pair. So in the previous example, if you recall, A was AB and this set B was just this element C. So A cross B was AC and just BC. Okay, this set whole. Now we use this term in the Cartesian product ordered pair. So these pairs are what? Ordered pair. We are saying these are ordered pairs. So what do we mean by this term ordered pair? Ordered pair means that if two pairs are equal to each other then equal to each other if and only if the first element must be equals to the first element in other pair and second element must be equals to the second element in the other pair. Okay, so what this means is, so for example this pair, this 2 comma 3 pair is not equal to 3 comma 2. So this 2 comma 3 pair is not equals to 3 comma 2. Why? Because 2, the first element of this pair, first element not equals to first element here in this pair. Okay, and also the second element also not equals to the second element over here. Okay, so not equals. Now another example, so like this, does 2 comma 3, does these both given pairs equal or not? Equal or unequal? What if you see the first element? So first element is equals to first element over here. Yes, but if you try to see this, the second element not equals to second element over here. Okay, so this means our answer would be what? Not equal. Okay, now then when do we say that the given two pairs are equal to each other? This means, so 2 comma 3 is equals to 2 comma 3. Why? Because first element over here, first element is equals to first element over here, first element. Okay, and second element is equals to second element over here. Okay, I hope that from these examples you can now say that what two pairs are equal and what two pairs are not equal to each other. Okay, I hope that now it is clear, the ordered pair meaning. Now this thing, that if P number of elements in this set A and Q number of elements in this set B, then there will be P times Q element in this set A cross B. Okay, in other words, number of element in this set is equals to P, number of element in this set is equals to Q, then total number of element in the Cartesian product of A and B will be what? P times Q. So how we are saying that? Quite easy. Try to see that in A cross B, yes, in A cross B, we want what? Pairs here A, B, such that A belongs to set A and B belongs to set B. Okay, then for example, if you try to see, for example, what? A is just this and B is what? Just this. Then A cross B, how will you write? Just write. So this pair element, the first element of the pair comes from which set? This A set. This means 1. We can easily see that there is only one element. So 1 comma. What I can write over here? I can write 2 or I can write 3. Yes. So first of all, let me write 2 and then I will write 3. Okay. Clear? Are there any other possibility? No. Yes. So the only possibilities are 1 comma 2 and 1 comma 3. So how many you got? Just 2. In this, how many elements you got? Just 2. And if you try to see, the number of element in this set is 1 and the number of element in this set is 2. So 1 times 2. Okay. Now what? Now, as we know, in A cross B, if A number of element A is P and number of element in the set B is Q, then A cross B will be what set? As you know, A cross B will be set pairs in which the first element comes from this set and second element comes from this set. Okay, so A, B belongs to B. Now, if you try to construct this set, how will you start? You will start the first element. So let me write that if A set have P elements, this means I can take A1, A2 and so on till P. These elements. Okay. Okay. Same with B. I can take B as B1, B2 and BQ. Yes. So here Q elements, and here how many? P elements. Okay. P elements. Okay. Now what? Now from this what you can say, if I am going to write this whole set, then how will I write? Quite simple. So as you can see, so first of all I will write A1 and then the second element comes from what set? This whole set B. So I can write B1 here. Yes. I can also write A1 with B2. Yes. Until I can write A1 with BQ. Yes. So how many element I have got in this single row? This 1, 2 till BQ. So Q elements. Sorry, Q pairs. Okay, Q pairs. Same thing I can do with A2. So A2 pair with B1, A2 pair with B2 and so on till A2 pairs with BQ. Okay, so in this row how many pairs I have got? q number of pairs. So q number of pairs, and I can do this for every ai till p. The last element is what? ap. Okay, so ap with b1, I can pair ap with b2 till ap with bq. So in this row I've also got q number of pairs. So as you can see, for every row I am getting q number of pairs. And how many rows I will get? I will get, so 1 row, 2 row till q row. As you can see, the total number of rows, total number of rows p, and in each row, in each row we have how many pairs? We have q number of pairs. We have q number of pairs. Yes. So this means, this imply total number of pairs will be what? P times q. Yes. Or in other words, you can say q plus till q, and these q will be added how many times? P times. So this means, in other words, p times q. Okay, so that was your what? The total number of elements or the pairs in a cross b set. Okay, p times q. I hope that now you have some idea how we got here. Okay, let us move to next. Now we come to our definition of relation. So what do we mean by relation? So in a normal or daily life, if you recall, what do we mean by relation? Relation is just nothing, describes what? Describes a relationship between someone to someone. Okay, okay, I hope that it is clear. So for example, if you try to see that say in a family, we have a family A. I have say another family, or I have two group. Okay, I have two group, A and B group. In A group I have Arjun and Dev, and in B group I have Suresh and what? Binod. Okay, and the relationship is like this, that Arjun is son of Binod and Dev is son of Suresh. So this is what relation means. The representation or the describing relation between two elements or in between two groups. As you can see, A and B groups are related like this. The son, this is what you can say the son group, and this is what you can say the father's group. Okay, and the same will happen in maths also. So a relation in mathematics defines the relationship between two different sets of information. Okay, and relation in maths is a subset of the Cartesian product of two sets. As you can see, for this, from this example, what you can say is very clear, that if you try to find this Cartesian product, what you will get? You will get Arjun pairing with Vinod. Okay, and also Arjun pairing with Suresh. Yes, and now Dev pairing with Suresh and Dev also pairing with Binod. Okay, this was the this is from the definition of the Cartesian product A cross B. Clear? The first element of what? The first element in the pair must be from what set? This set. And the second element in the pair from which set? This set B. As you can see, the whole A cross B set will consist 4 elements. As you know, the number of elements in set A to same with the number of elements in the set B. We know the total number of elements in this set will be what? 2 times 2 means 4. As you can see, 1, 2, 3, 4. The total number of elements. Okay. And the relation is defined like this. As you can see, this will be our relation. Okay. So as you can see now that my relation from A to B is what set? My relation is what set? Arjun related to Binod and Dev related to Suresh. Okay. And if suppose this set is given, this relation is given, then I can take what information out? I can easily tell that Arjun is son of Binod and Dev is son of Suresh. In other words, Binod is the father of Arjun and Suresh is the father of Dev. Okay? Okay. So as you can see now that R, this relation or this set R is a subset of this set, as you can see. Yes? So A cross B. And it generally holds that in maths, relation is a subset of the Cartesian product of two sets. Okay, this generally will be true. Okay. Okay, I hope that it is clear to you now. Let us move to the next. Now, a relation from a non-empty set A to a non-empty set B is a subset of a Cartesian product A cross B, as we already saw. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B, as we saw from an example that we described what a relation which says that A, the element of A must be son of element of the set B. Okay, I hope that it is clear now. And the second element, we called it as image of the first element. So this means R set, this relation R is equals to will be what? Subset of A cross B. Okay. And this relation, this elements from this, which means A comma B belongs to R, and this second element, what we are calling it, what we are saying to it, we are saying that B is the image of the first element. This means B is the image, or we can say B is a image. B is an image of the first element, and first element is what? A, here A. So B is an image of A. Okay, I hope that this term is also clear to you. What do we mean by image? Okay, when we are talking about image, then we are also talking about the first element. Okay, image is what? The second element in a pair. Okay, I hope that it is also clear to you. Okay, now let us move next. Now what? The set of all first elements of the ordered pairs in a relation are from a set A to set B. We call it as domain. So what do we mean by domain? Domain is just nothing, collection of all the first elements. What this means? For example, if a relation R, if a relation R is equals to like this 1, 2, 2, 3, 3, 4, that's it, then domain will be what? Is equals to set of all the first elements in a pair. Okay, So this means like this, this and this. So your domain will be 1, 2, 3. I hope that it is clear. And if you try to see this, the what? The set of all second elements in a relation from A to B, we called it as range. So this means range will be now, range set will be what? Set of all the second elements, set of all the second elements in a pair. Okay, or we say set of all. Okay, so set of all the first elements, as you can see, and set of all the second elements, as you can see, this 2, this 3 and this 4. This means 2 comma 3 comma 4. Okay, okay, I hope that this is all clear to you. Quite simple, the definition for domain and range. And what do we mean by codomain? Codomain means if my R is from A set to B set, this B set, this whole B set, this whole B set, the whole set B, we called it as what? Codomain. The another name for this set is what? Codomain. I hope that it is clear to you. Okay, and also try to see that range will always be subset of codomain. Yes, range will always be subset of codomain. Okay, I hope that it is clear to you. Let us move to next. Now, relation representation. How we are going to represent our relation? So our relation may be represented algebraically either by the roster or by the set builder form. As we saw in previous example, the relation we defined, if you recall, son to father was like this: Arjun by Suresh, I think, and Dev by Arjun by Vinod, I think. Okay, and Dev by Suresh. Okay, Dev and Suresh. So this is what? The roster form. Roster form. Okay, and if you try to put it in a set builder way, how will you write? You will write that this collection of all pairs such that A belongs to, or we can say A belongs to what set? Say Arjun and Dev, and B belongs to what set? Vinod and Suresh. Okay, so this is what our set, not a pair. Okay, so set, and where A must be son of, A must be son, we can say A must be son of B. That's it. In set builder form we write like this. So collection of all AB such that A belongs to this set, B belongs to this set, and the relation is defined by this: A must be son of B. A must be son of B. Okay, as you can see, Arjun son of Vinod, Dev son of Suresh. Okay, I hope that it is clear. And arrow diagram also we can represent by arrow diagram. For example, this set A, in set A elements are Dev and Arjun, and in set B elements are Suresh and Vinod, and we know Dev is related to what? Dev is related to, as you can see, Arjun, yes, Dev is related to what? Suresh, and Arjun is related to whom? Vinod. So Dev to Suresh and Arjun to Vinod. So this representation we call it as arrow diagram. Okay, I hope that it is also clear to you now. Okay, now let us move to the number of relations. So possible number of relations. So how many possible number of relations can you find of A cross B? So it is quite simple. When we talk about what? relations, we already know that relation must be subset of A cross B. This means what we are looking for? We are looking for total number of possible subsets of the set A cross B. Yes? Yes? Yes. So we know what we know. We know if the number of elements in this set X is equals to n, then the number of subsets of X will be what? The number of subsets of X will equals to be 2 power n. Okay, this happens. So if the number of elements in the set A is equals to what? P, and in B it is equals to Q. So this means P and this is equals to Q, and we know this imply what? Total number of element in A cross B, PQ. This means that this means possible subsets of A cross B will be what? 2 power PQ. So this number will be what? My total number of possible relations. So total number of possible relations will be what? 2 power PQ. Okay. I hope that you understood it everything very clearly. So that's it for today. We will meet soon. Thank you.